Hi everyone, I'm Taegyoku from Midas IT. If you can hear my voice, please say OK in the chatting window, please. Thank you. I will start my webinar in 3 minutes. Thank you for your participate, and I'm very glad to be here to introduce Midas Gen. Okay, thank you. I will start my webinar in 2 minutes. Okay. Um, how are you? My name is Taegyoku from Midas IT. I am very glad to be here to introduce Midas Gen, window-based general-purpose structure and analysis and optimal design system based on finite element system analysis. Today, in third webinar, I will introduce the steel structure design. As you know, Midas Gen is used in many different areas such as stadium, power plant, airport, hangar, and underground structure and such. Here you can see the contents for today's training webinar. Topic for today is Introduction of Steel Design. I will practice the multi-story for those who are not familiar with the steel design functions. Then after Q&A, I will send you the email about the survey. In the survey, there are some questions. Please fill out those questions. And also in the last question of the survey, if you need the certificate about this webinar, please just check on for that. And we will send the certificate in 1 week. And survey will be sent tomorrow or day after tomorrow after this webinar. Also, I will send the PPT file and recording file about today's webinar. If you have any question, please use this window, question window. I will give you the answer end of this advanced webinar. Okay, let's start. If you see the contents here, you can see the simply what I will touching down. Today, we have the general session for the steel design in Midas Gen. The main purpose for this online training is to introduce some useful feature of Midas Gen, focusing on the member design for steel structures. Also, through this session, you can build your capability of effective implementation in steel design. In first chapter, I will introduce the design feature, then explain about the steel design. Next, I will demonstrate the steel design building and introduce briefly about the steel optimal design function. And then I will get the Q&A session. This slide shows the available design code in current Midas Gen. You can see the RC. First of all, I will introduce this slide. The following feature, as you can see, is available in Midas Gen. For the RC structure here, concrete code design and code check of the beam, column, wall is available. Also, for the seismic zone, we can perform the RC strong column and weak beam design. And slab and wall design for the plate element is available. Also, for the footing, we can design the isolated footing, and pile footing is also available. For the steel structure, we can design the general frames. Also, steel optimized design is implemented in Midas Gen. This table shows the available design code of current Midas Gen. You can see the RC, steel, SRC, and footing and slab design for the America, Eurocode, British, Indian, Canadian, Chinese, Japanese, and many different and many international building codes. Those are implemented in Midas Gen. Following steel design features are available in Midas Gen. Gen provides code check for the beam, column, and bracing. Also, ultimate state limit state and serviceability limit state can be checked. Static wind load can be automatically assigned, and seismic loads and response spectrum is available in Midas Gen. Also, available section profile include, as you can see here, angle, channel, I-shape, T-shape, box, pipe, double L, double C sections. Those sections profiles are available in Midas Gen, and imperfections need to be manually considered. And second order effect can be considered in Midas Gen. Internal forces and moments are determined using elastic global analysis, and composite beam design is provide the Midas family program, which is the Midas Civil, and capital design is available as per the Eurocode. And I will explain with the detail. In this chapter, I will introduce the steel design in Midas Gen based on Eurocode 3. I will talk mainly two different parts, ultimate limit state check and serviceability limit state check. In ultimate limit state check, as you can see the followings: the material properties section table for the application of ultimate limit state check, and resistance of cross-section and buckling resistance of members. I will introduce with this follows. And the serviceability limit state check, vertical deflection and horizontal deflection. I will explain it simply. Okay, this slide is about the ultimate limit state check. You can see in this table, the different yielding and ultimate strengths are considered according to the section thickness. If the thickness is larger here or smaller than 40 millimeter, the value of yielding and ultimate strengths are differently applied in Midas Gen. Also in Midas Gen, we can use the database, or the user can define their own property, such as the modulus elasticity, Poisson ratio, tensile strength, and yielding strength. So click here, and user can define the steel material. Also go to model and go to the property and select the material and click add. Here you can see user can enter the value for the modulus elasticity and Poisson ratio and thermal coefficient and the weight density by user defined. This user defined function can be performed the analysis, but user cannot see the design result because the program cannot distinguish whether this user defined is steel or concrete or SRC. Therefore, if users want to define the steel with their own property values, we need to go to Steel Design tab here and select None, and user can define their own value here for the modulus elasticity, Poisson ratio, and thermal coefficient, and such. Next, this slide shows the ultimate limit state check according to cross sections. For instance, in Midas Gen, user can see the yielding and flexible flexural buckling for all sections except the U ribs. For the shear buckling, only I section and channel here and box and the double channel are available. For the weak axial, this is the strong axis, and weak axis, only the box is available to check the shear buckling. For the lateral torsional buckling, only I section, the double symmetric I sections are available. Double symmetric I section is the section that have identical area and shape both top and bottom flange. Next is the resistance of the cross section. Resistance of the cross section is calculated as per Eurocode 3. For the design tension resistance and design compression resistance, program apply the as you can see the formula here. Especially for the compression, program applies the class 4 section with the user of effective area to calculate the compression resistance. Here you can see the EFF, this value, this letter. EFF, which is the effective area, is determined assuming that cross-section is subject only to stress due to the uniform axial compression. And design bending resistance is calculated according to the section class, same as the compression. And effective section modulus, which is the EFF here for class 4, is also determined assuming the cross section is subject only to bending stress. And design shear is following here with this formula. And shear buckling resistance is calculated by the summation of resistance, both flange, here you can see this formula, flange, web and flange. And stiffener designed to resist the shear buckling is not provided actually in Midas Gen. Stiffener type for end support is assumed as non-rigid end post. Torsional resistance is not checked. You cannot check in Midas Gen. Next, this is the combined effect of the bending and shear. And this slide shows the combined effect of bending and axial force. Midas-Gen provides a resistance check considering combined effect of the bending, shear, axial force. The member which have the axial force and biaxial moment are checked by those two formulas. Here you can see. And next is the buckling resistance of the members. Fracture buckling for the uniform member force compression is checked as following. Once again, we will send, actually after this presentation and the demonstration about the steel design, I will send this PPT material and the video, the recording file to you. Also, what I talked so far about those formula, I will show you during the demonstration with the detailed reports. Next is the uniform, and actually for the uniform and doubly symmetric cross section, the lateral torsional buckling check is provided in Midas-Gen. And here the MCR is the elastic critical moment for the lateral torsional buckling, and this C factor, which is the critical factor. C factor is used to calculate the elastic critical moment, that is the difference according to the bending moment diagram of each members. And from both table, with this table and this table, we can get the C1 factors. Finally, program calculate the lateral torsional buckling resistance by this formula here. And the member which have the biaxial bending and axial compression use this formula and then check the buckling resistance. The moment My and Mz here, My and Mz in this formula is the member force which occur in I and J end in same time. Actually, after from the next version, Midas-Gen will be implemented. The option that the user can input the maximum value My and Z for the member. Next is about the serviceability limit state check. For the serviceability limit state check, we can check the vertical deflection for the beam and horizontal deflection for the column. Overall horizontal displacement over the building height h should be checked separately by the users. Also, the vibration here structure is not checked in Midas-Gen. And so far I will explain about Eurocode 3, and during my demonstration all this the formula you can see in the detailed report, and I will explain it with the details. Okay, next I will introduce the steel structure design method in Midas-Gen. Actually, Midas-Gen has two different methods for steel design. The first one is the program check the strength and serviceability based on the sections defined by user and design code selected by the user. So which is the steel code checking function. Also, the program search and propose the section which satisfy the design condition entered by the user. Then the users can update the section referring to the sections proposed by the program. Secondly, program find the optimized section for the gravity load, which is the steel optimized design function. With the combined use of two methods, the user can find the optimized sections. In this webinar, today's webinar, I will introduce those two methods, which is the still code check and still optimal design. This model is 5-story building, consists with beam, column, and bracings. I will apply Euro code for this building. And this building is braced frame system. And this building has 5 different loads, as you can see: the self-weight, superimposed dead load, live load, wind load, and seismic load. Superimposed dead load means the second load, which are the curtain or window glasses and such. And this slide shows the applied sections for the beam, column, and brace. Let's start with the model file. Okay, this model, as I mentioned, is 5-story building, consists with the beam, column, and here the brace. Here you can see the worktree, and you can see all the input data in one side. I already input the load, as I mentioned, such as the self-weight, floor load for the dead load and live load, and wind loads and seismic load as per the response spectrum. Also, boundary conditions are applied here. And I assigned the beam end release to release the bending stiffness at the both end of the beam elements. Okay, let's start. Let's perform the analysis. And to see the results, go to Result and click. Firstly, I want to check the displacement of a model by displacement contours. You can see the displacement contours. And we also can check the shear force and bending moment diagram for the beam elements. So go to Force tab here and select the beam diagram. And click Apply. I will see the solid fill. So you can see the shear force and bending moment diagram. This is the actual bending moment diagram for the beam elements. For the shear force, you can just click and select. You can see the shear force for this building. And this exact and 5 points, I will explain about this function. This exact is the, let's select one element here and activate it. Okay. If you select the exact, this option, it's display the member force calculated by the detailed analysis process all along the length of each beam. Elements include the both end nodes. And these 5 points is simply display the member force calculated at both end nodes and the quarter points of each beam elements. You can see some different. And actually with the quick view, we can see the beam force diagram, detailed diagram for the element in this window box by clicking each beam. Okay, then I will start the design. Go to Design tab and go to Steel Design Parameter and select the design code. To apply for the strength verification of the steel member, let's determine the design code here. In my case, I will select the Eurocode 3, and you can see the many different codes in many different countries: America, China, British, Japanese, and Taiwan and such. And click OK. And I will generate the load combination. Go to the result and combination here. Users should generate the load combination in the Steel Design tab. To apply the Steel Design function, similarly, Concrete Design tab for the Concrete Design function. Actually, load combinations generated in this general tab are not considered for the design functions. If you generate the load combination, in this case, I will generate the steel load combination. And you can see the wind load here. Program automatically provide both positive and negative direction of wind loads. So users do not need to define both directions. Also, user can modify or delete the load combination. I can change the load combination like this. And with this spreadsheet form, if you click it, you can just copy and paste from the Excel to this load combination dialog box directly, or you can just copy and paste from here to the Excel. So user can input their own load combination with the easy method. Okay, I finished to generate the load combination and go to the Design tab again. Steel Design Parameter and click the Modify Steel Materials. This function is to modify a part of the steel material property data entered during the creation of analysis model. You can modify from here. Also, as I mentioned earlier in the beginning, user can input user-defined value in this window by selecting None. You can input your own desired value here. And for the emplaced lengths, to define emplaced lengths, go to the General Design Parameter and select emplaced lengths here. If the 0 is entered here, for the Ly and Lz, emplaced lengths will be calculated by the program based on the nodal coordinates of the beam elements. In my case, in this case, I will select the only section for this 1 and 2 section. Click Add and apply the laterally emplaced lengths manually about 2.3 meter and click apply. You can see datas are entered. Okay, then let's enter the equivalent moment correction factor. Go to Design tab again, General Design Parameter, and go to Equivalent Uniform Member Factor. This function is an adjustment factor for the moment magnification factors. So once again, select this one. Select identity, this window box, and in my case I will only apply for the beam, and click calculate by the program and apply. The factors, uniform moment factors are applied here, and we can enter the strength reduction factor with the partial safety factor. So go to the design and still design parameter and click this partial safety factors. Strength reduction factor, which are a form of safety factor to account for the difference between the nominal and real strengths of the material. Also, the difference in member strength between the design and manufacturing or construction. So, click this update by codes. When the strength reduction factors are not entered in -gen manually, then strength reduction factors specified in the current design code. So in this case, I will define Eurocode 3 and the partial safety factor implemented based on the Eurocode 3. Click close and go to the design tab and general design parameter, and let's see the serviceability load combination type. Once we generate in the load combination here, still design tab here, once we generate the load combination as I showed you previously, load combinations are generated using the auto generation. The program automatically assigns the quasi-permanent and frequent and characteristic load combinations. Let's define the control parameters of deflection for the serviceability check. Firstly, I will identify the select the member. In this case, I will select the beam and click close and go to design and still design parameter. Select the serviceability parameter here, and I will use the default value for the deflection control for beam and column. And deflection amplification factor also use just value 1 and click apply. If the element local x-axis is parallel to the global z-axis, the element is considered as a column in -gen. In other hand, if the element local x-axis, this is the x-axis, is parallel to the global xy plane, the element is considered as beams. All other members except the column and beam are considered to the brace in -gen. So program automatically consider this one as a brace. And next I will apply the live load reduction factor. Again, go to Design tab and go to General Design Parameter and select the Modify Live Load Reduction Factor. This function is used to reduce the live loads for column, shear wall, or foundation when calculating the required actual strengths. I will enter the basic data required to calculate the live load reduction factor. To input the live load reduction factor, firstly, select the elements that you want to apply the live load reduction factor. In my case, I will select only the column. Only the bottom column here. Again, go to Design and General Design Parameter and modify Live Load Reduction Factor. Reduction factor, I will just decrease the 75%. So just enter 0.75 for the actual force and click Apply. You can see the data is implied in the column here. Okay, I will perform the steel coat check. Go to Design and click this steel coat check. And you can see the window dialog box, the result you can see in one side. And this COM, I will explain simply. This COM is the critical ratio by axial force and bending moment, which is the yielding and buckling. And the SHR is the critical ratio by the shear force of the yielding and buckling. And if I select the graphic here, the button, select one element and click the graphic. This is one page summary. You can see the design information here, the codes and the units and such, and section name and member length. And you can see the checking result here. This checking result shows the ultimate limit state check results. So you can see the actual resistance, bending resistance, combined resistance, as I earlier mentioned in the slides, and shear resistance. Also, deflection checking result. This is about the serviceability limit state check result. So you can see the deflection checking result and the checking result for the all resistance. And I will show you the detailed formula and calculation in the detailed report. In this time, I want to see the detailed report for the column. So this one, I will select it and click the detail. In the detail report, you can see all the formula and the way to calculate. So firstly, in the detail report, you can see the section property. In the section property, there's the WLEY and WELZ and WELY. WELY, this W value, is the elastic section modulus, and WPLY is the plastic section modulus. This is the elastic section modulus. And you can see all the input value, area, and everything here. And I will show you how to determine the class specification. As you can see, the right top and left bottom, right bottom, and all those the calculation. Actually, program check the left and right of the both top and bottom flange and the center, which is the web. Among those 5 different parts, program select the lowest class and determine the section classification. In this time, as you can see, all of the class is determined by class 1. So program think this column is class 1. Next, we can see how the program calculate the axial resistance. First of all, program calculate the axial compressive resistance of the closed section. You can see the formula. This formula is same what I shown in the slide before in the beginning. And then after the calculate the axial resistance, then program calculates the buckling resistance of the member. Buckling and axial resistance is satisfied for this code. This shows OK. And this is the NG model, so it's not accepted. I will change the section after this, explain about after this the detailed report. But axial first is OK, satisfied. So, and then also we can see the shear resistance. Actually, in this column, you can see the shear resistance, the value here. And then we can see the bending moment resistance about the major and minor axis. This shows the checking result for the bending moment resistance about the major and minor axis, and you can see the combined you can see the combined resistance. Program can independently check the compression, shear, bending moment, as you can see before, and after that we can see the result of the resistance check about the combined effect. So Rmax1 here is the resistance check about the cross section, and the Rmax LT here is the resistance check about the buckling. Both results are the critical value. Finally, we can see the deflection result in the end of this detailed report. Okay, so far I will explain about briefly about the formula and the factors in the detailed report. Then I will change the NG section, this NG section, to make the satisfied section. So To change this section to satisfy, click this change button and define the limit combined ratio. I will use the default value and search satisfy section, and program automatically search. Select the member that you want to change and click this change and close button. Program automatically apply and NG going to change to OK. Also same, click this change button and search satisfy section and select the one elements that you want to select and click change and close. And you can see the section is changed. However, only the section for design review has been changed in this the window dialog box. The section in the model has not been changed as seen in the workstream. This is not changed, not same thing. So go to click this update button and select it and click this one, this arrow, and click yes. And click on this reanalysis button and click this recheck button. And you can see the workstream also changed, and all of the NG section, unsatisfied section, changed to the satisfied section, and this structure is safe now. And I will explain about the bracing. As you know, this is the bracing. And nonlinear analysis using the tension-only elements does not have any relative result with the linear load combination. It is because the stiffness of structures that are used dead load analysis is different with the wind load analysis. In this case, we need to generate the static load case, include dead load and wind load. And as you know, this brace is the tension-only element, so we should generate the static load case, include the dead load and wind load. So in -gen, we can use to generate this, as I mentioned, for the bracing. So firstly, I will change the section property. Go to element and change element parameter. Element type going to be truss to tension only because this is the brace. Brace is only act as a tension, and click apply. You can see the element is changed here, and generate the static load combination. Go to load and click this create load case using load combination, and select the load combination and define one of the load combination here. type is just user defined, and click add. And apply. If you click apply, you can see the input data here. And I will delete the p-delta analysis data because the tension only elements cannot interact with the p-delta analysis in MIDAS-Gen, and perform the analysis. And go to result and go to the beam diagram and click this 3 dots and select this one, static load case that I defined, and click OK. It shows a lot of the elements, so I will specify only element 80. And again, if you click OK, then it shows, and the value is different. So user need to define to see the result of the tension only should be the not just normal load combination, it should be the static load combination. And MIDAS-Gen, in the MIDAS-Gen you can generate the static load combination. In summary, for the tension only elements such as the bracing, user need to generate the static load case to get the correct results. So this top is the correct result. Okay, this is the overall detailed procedure and explanation for the steel design. Next, I will explain about the steel optimal design. Steel optimal design is also implemented in MIDAS-Gen. Firstly, I will open the model file for introduce this function. Okay, this is also the 5-story building. And in order to find the optimized section, you can perform, which is the easy way, which is the optimal design function. By performing optimal design, you can see a variety of type of graphs as a result. If you want to perform the optimal design using the database in MIDAS-Gen or your own database, you can directly specify your desired section shape, dimensions into the program. I will show you the optimal design. For the optimal design, I will use this model file as I mentioned. After generate the load combination in the same way, define the design code. I will use the Eurocode 3 and select the design. Firstly, perform the analysis and select the design and click this Steel Optimal Design and perform Steel Optimal Design. Firstly, perform the general steel code check based on the steel design, based on the design codes. And then by specifying the number of iteration and the method of optimization, we can perform the optimal design. As you can see, this is the result of the still code check. If the ratio is less than 1, it means all the sections are satisfied with the code. And then we can check this design criteria in this window box, dialog box, and actually we will use the UNI section with the shape I. This D1 represents the height of the section, so program will find the optimized section based on this value. And plus minus 5% of this height will be checked in the UNI section database. And I will define the number of repetition. In this time, I just, to save the time, I just define the number of iteration 1, click OK, and then perform the design and analysis. Click this button. And before I click this button, definitely I should select the section. Because of time consuming, I just define some of the few sections. Okay, this particular section, I will find the optimal section and click this design and analysis. Okay, we finished to performing the optimal design. And see the graphic result by clicking the graphic report here. You can see the graphic result. Go to Window, select the vertically. Yes. If you see the graphic result, especially for the weight, we can see how much weight is reduced and the average ratio and such. You can see in this graphic, you know the original and what I do the optimal design. You can see the weight going to decrease in this much, and you can save the money. And you can see all of the detailed graphic report in one site. Also, by clicking the text report, you can see the text results with those details information, and you can save it. To update this section to the model file, please click this model update button. Program perform the analysis and the sections will be automatically updated. as you can see from the window dialog box here. Okay, I finished my optimal design demonstration, and as I mentioned, I finished the steel code design for today's third webinar. And if you have any questions, please ask me, and I will kindly answer for your questions. Thank you so much for your participation, and I appreciate it. So if you have any questions, please leave your questions in the questions window, then I will answer for you. Thank you so much. Mr. Stanley Shum, you asked me, is it will be okay if the Midas Gen includes a sine load and impulse load instead of the just fixed dead load and live load? As you can see in this dialog box, we have the sine load and impulse load here. You can define the name, and yeah, we provide in Midas Gen. Mr. Silvio Ginju asked me we can perform the floor violation analysis and joint connection design in Midas Gen. We can perform the flow violation analysis in Midas Gen. It is available. However, joint connection design is not available in Midas Gen. Leg Karel Johan asked me, as I understood, the Midas Gen cannot design the I-shaped beam bending about the weak axis. No, in Midas Gen actually, you can design the I-shaped beam bending about the strong and weak axis. Stanley Shum, if you want to draw in GTS and import this model into the Midas Gen, actually in current condition it is unavailable. However, we have the FX Plus, and you can draw the detail modeling, 3D modeling in FX Plus, and you can easily just click to import those 3D model into Midas Gen. Also, the certificate is provided in the PDF file format. If you need the format, then individually ask me. I will answer for you. Thank you. Yeah, if you have any additional question, there's no more question, I think. So if you have any additional question, please send me in the email, which is the support at Midas it.com. We will individually answer for you. Thank you so much for your participation for today. Thank you.